A gamma ray, also known as gamma radiation, is a penetrating form of electromagnetic radiation, a boson, arising from the radioactive decay of atomic nuclei. It consists of the shortest wavelength electromagnetic waves, typically shorter than those of X-rays. This means when these bosons travel, they move in undulations, going up and down, instead of going straight like a particle would do. When the up and down movement is completed to start another, this is called a cycle, measured in hertz, cycle per second. With frequencies above 30 exahertz, that's 30 followed by 18 zeros, take that, you know who, gamma ray bosons have the highest photon energy of any form of electromagnetic radiation. The photons are a type of boson, so is the gluon. Paul Villard, a French chemist and physicist, discovered gamma radiation in 1900 while studying radiation emitted by radium. In 1903, Ernest Rutherford named this radiation gamma rays based on the relatively strong penetration of matter, as in 1900 he had already named two less penetrating types of decay radiation, discovered by Henri Becquerel: alpha rays, the charged helium 4 particles without electrons, and beta rays, the lepton radiation from beta decay, in ascending order of penetrating power. Gamma rays from radioactive decay are in the energy range from a few kiloelectronvolts, keV, to approximately 8 megaelectronvolts, MeV, corresponding to the typical energy levels in nuclei with reasonably long lifetimes. The energy spectrum of gamma rays can be used to identify the decaying radionuclides using gamma spectroscopy. Very high energy gamma rays in the 100 a 1000 tera-electronvolt, TeV, range have been observed from sources such as the Cygnus X-3 microquasar. A microquasar is a binary gravitatory stellar system, consisting of a main sequence star and a gentle black hole, most probable formed from the remnants gases and core of a supergiant star that went hypernova, and the gravity of the core, now a black hole, created a disk of plasmatic gas as far back from it as Jupiter is from the Sun, forming over the course of the next couple of million of years a new main sequence and smaller star. Natural sources of gamma rays originating on Earth are mostly a result of radioactive decay and secondary radiation from atmospheric interactions with cosmic ray particles. However, there are other rare natural sources, such as terrestrial gamma ray flashes, which produce gamma rays from electron action upon the nucleus. Notable artificial sources of gamma rays include fission, such as that which occurs in nuclear reactors, and high-energy physics experiments, such as neutral pion decay and nuclear fusion. As good this is for science, gamma rays can ionize atoms and are thus hazardous to life. They can cause DNA mutations, cancer and tumors, and at high doses burns and radiation sickness. Due to their high penetration power, they can damage bone marrow and internal organs. Unlike alpha and beta rays, they easily pass through the body and thus pose a formidable radiation protection challenge, requiring shielding made from dense materials such as lead or concrete. So, which is your favorite boson?